Hello, we are going to understand gravitation. If I left this ball in this space, it falls to the earth. Have you ever think that why this ball goes to the earth? Why doesn't this ball goes away from the earth? So definitely there should be a cause which causes this ball towards earth. So it's a nothing but it is a force that is called gravitation. Gravitation is a fundamental force. In fact, everything in the universe, even though in this screen whatever you have visible like this ball, this earth and surrounding attracting each other with gravitation, but here earth mass is very large, so earth is dominant here. This balls, since this ball falling to the earth, there is definitely a force. So as you have learned, if there is a force, definitely there is an acceleration. So by this gravitational force there should be acceleration. So we will calculate the acceleration as well as a force formula. So here if I left this ball, it's fall down. Here just this ball is falling. This is called free fall. In the free fall we doesn't giving any force. It's just I'm just lefting this ball. In this case there is only one force, that is by gravitation. So this case is called free fall. Now let's understand the difference between weight and mass. Look at this ball. This ball can be compressed. So we can say there is a vacant place in the object. So there is a less mass. And these bricks have more mass. So mass is fixed. So number of molecules or atom in this object is a constant. If I go to another planet like moons, Jupiter, have the same number of molecules and atom, it cannot be changed. But weight can be changed. What is weight? What is feeling the force on my hand at this time? This is weight. So weight of this object and weight of this object is a different. And but take a scenario of only this case. If I go to another planet like moons, there should be a different force on my hand. Means if this is 50 gram, there could be a 25 gram. That is the difference between mass and weight. So it depends on the gravitational acceleration. We will calculate how it can be calculated. Now we will understand universal law of gravitation. Actually this law tells we can calculate the force between any two masses of gravitation. So here capital M, there is a one mass and another mass, a small m, and the distance between these two masses is d. So force at F1, force at a small mass m, that is F1, and force at larger mass m, that is F2. So as per universal law of gravitation, F1 can be written as F1 directly proportional to product of these two masses and inversely proportional distance square of distance between them. So F1 equal to G m over d square a cap. Since we change the equality, so definitely there should be some constant, and this is a representation of the vector quantity. Since this force is a vector quantity, so it's a nothing but it's a direction of that force. Now we are going to understand free fall. This mass is in space. I left this mass and it's just start falling down due to this force F, capital F. Distance between the center of the earth and the center of mass is a small d, and the distance between earth's surface and the mass is small r. As we have seen previously that F can be written in this way. And also if there is a force of at a mass, that can be written in this way, that is mg. Since mass have some acceleration, so I just let this value should be g. So mg equal to, this equation can be equated, and mg equal to g capital M small m over r plus d square. Since this small r can be written in this way, this mass, this distance plus this distance. That's also this r, capital R, is very larger than small r. Since we are assuming that the object is near this earth surface, so this r will be very less than a capital R, that is our radius of earth. So our result is this, that is we are calculating here acceleration due to gravity of earth. So this is g m capital M over r square. In this expression everything is every term is constant, so g value will be constant under the assumption that is object should be near the earth surface. Now we understand the weight of mass. Suppose we are on earth with mass, this mass, and at the earth we have a weighing machine. So the force acting on this weighing machine by this mass is F, equal to this mass multiplied by G. So G is, we have seen what is G, that is, so for this this is constant for this earth. So force on this machine is nothing but the weight of that object. So suppose the reading is 15 kg, and the same scenario, let's assume we went to the moon. At the moon we know the g can be calculated in this way. Since here this is radius of earth, definitely this should be changed and it should be radius of moon. So this will be different from earth. So here the weight of object will be vary, since here weight equal to mg dash, since g changed. That's why it should be less than, if g is less than this g, definitely if there is 15 kg, there should be 10 kg. So weight can be changed with respect to the gravitational force depending on the gravitational acceleration.